You did?
I clicked it.
All right, cool.
All right, well, let's get this show on the road. Good evening, everyone. Are we live? Everybody confirm we're live there?
Yep, we're live.
Welcome to the July edition of the Parker Radio Association Elmer Night. It would be absolutely fantastic tonight if we could meet in person, but you know what? This is almost as good as being in person. And we've got a fantastic show for you tonight. And a lot of people on YouTube Live and a lot of people on Google Meets. And it's good to see everybody here. Good to see some faces I haven't seen in a while. See Gary in there and Mike and some other people. And hey, Ray, see you in there, buddy. You're looking good. And Elizabeth. So anyway, we're really glad you're here tonight. My name is Paul, AC5S, and I am one of the committee chairs for the Elmer Committee. The other chair is Terry, WB3EBZ. And Terry sends his hellos and that type of thing, but he's over in Utah tonight, and he's probably still working actually, so he's not going to be able to join us tonight. But we do have a fantastic presentation for you tonight, and I'm going to introduce you to our presenter in just a second. Couple quick things. We do have a YouTube Live for our main face-to-face meeting coming up in August. That's our anticipation right now. The library is not giving us a whole lot of leeway. We can we're only allowed to put 12 people in that big room that we meet in. And that's certainly not going to work real well for the Parker Radio Association. So Justin, what are we up to now? About 165 people. Is that right? Or is my number off?
We're over 160. It's like 168. The prediction is by November, we'll be at 200.
Wow. 200. Fantastic.
By November.
Yeah. I think those of us that were in the first group of 13 are totally shocked and blown away by that number. So that's amazing. Well, we really do appreciate you all being here tonight. And we don't have a lot of announcements or anything like that. We're going to get right into our presentation. And tonight our presentation is I call this gentleman Mr. GQ. So that's how I'm going to introduce him. Mr. GQ, and his name is Tom, and he's been a member of the club for a couple years now at least, and he's all things ham radio in my mind. He's got a lot of good knowledge and a lot of information, and so Terry WB3EBZ put this presentation together. So thank you, Terry, if you are listening. I don't think you're out there. And Tom took it, offered to do the presentation tonight, added a few things of his own to it, and I can't wait. So without further ado, let's throw it over to Tom, Mr. GQ himself.
Unmute. And now that I'm unmuted, now I can thank you out loud. Let me go ahead and start sharing my screen so we can start in on this thing. Something that I really want to point out to you guys is this is really all Terry's work. I tossed in just very, very little, and I'm sorry that he is not able to present himself. I'm going to ask somebody to answer, can you see my screen, and can you hear me okay?
Yeah, roger that.
Thank you very much. Appreciate that. Just want to make sure it's getting out. What I'm presenting tonight is the result of some questions raised at another Elmer Net, and it was about antenna tuners. And this is what Terry has presented. He prepared the vast majority of this, and I really appreciate that. What we're going to talk about is antenna tuners, and this is an introduction. Not going to get into the math on how they work, anything like that. This is more of an overview. The questions we're going to answer is, what is an antenna tuner, and why would I want to use one? Let's go to that first one. And antenna tuners actually go by a whole bunch of different names: antenna tuner unit, ATU, transmatch, antenna coupler. And I do remember, I think it was back in the 70s when E.F. Johnson called their unit a matchbox. But to be honest, I remember it more for CB than I did for ham radio. One thing about antenna tuners, it's a lousy name because they don't tune anything. They do not adjust the resonant frequency of your antenna. What they do is they will match the impedance of your transmitter to the feed line and antenna. There's a lot of manufacturers of them that make them specifically. LDG and MFG are two that I know about. I didn't know what SGC was, but he does. Yeah, a lot of manufacturers make them. I happen to have an Elecraft 500 watt automatic tuner. So there are a lot of people doing that. Let's go and hit some basics here, shall we? And the first thing we're going to talk about in the basics underneath this, the very first thing is something that has more misinformation in it than almost any subject in ham radio except grounding. And when I mean misinformation, I mean it's got some wonderful lore out there. And of course, what I'm talking about is SWR, or standing wave ratio. What Terry wrote was it's a way to measure the mismatch in an antenna feed line system, which is absolutely correct. He does say it's the ratio of forward power to reverse power. That is the power that's leaving your transmitter, going to your antenna, and that which is reflected back. It's not an exact ratio. In fact, I'm going to throw some formulas at you. What it does do is it measures the match of impedance between your final amplifier and the rest of the system. If your SWR is 1-to-1, everything matches. And what he didn't actually mention in this slide, but is important to realize, is that if your source impedance matches your load impedance, in other words, they're equal, then you get all of the power transferred. If they don't match, then you get a reflection. And now I'm going to scare you with formulas. I put down VSWR, which actually stands for voltage SWR, which is what that first equation is with the Emax and Emin stuff. I should put I SWR for current SWR for the I. Doesn't matter. They're the same thing. And to be honest with you, we don't actually measure that because the maximum minimum is different parts of your feed line. It's a little hard to do. What we all use to measure it is an STBR bridge. We've got a reflectance bridge, which is kind of close to a single winding transformer with two secondaries. It samples some of the power off of your transmission line. And it has, through some diodes and some clever circuitry, can actually measure the power that is leaving your transmitter heading towards the antenna and that which is being reflected back. That's the third equation that you're seeing. That's what we really use right there in our SWR. The other equations are just to scare you. If you look, Z is impedance, and so that ZL is load impedance, ZO is the characteristic impedance of the line. The thing that looks like a hangman is the Greek letter gamma, and its reflection coefficient, and you can calculate the VSWR from that, and nobody does that because that's just way too much trouble. The last thing on there I tossed in because it's important to realize it hasn't been all that long that SWR was part of the amateur literature. It really started up for the most part in the 70s. Before that, people didn't worry about it. And even broadcast engineers to this day, although they're now adopting SWR as a measurement, they still tend to use something else called return loss, RL. And it's the forward power divided by the reflected power, the log of that times 10. The thing about it is it's backwards, meaning if the return loss is 0, that means everything you send out comes back, and that would be an infinite SWR. About the only time anybody really uses that is if you're a broadcast engineer or if you are Ray when he gets around to tuning the cavities for the repeaters that we have, because that's one of the measures that he's going to use. Terry found a nice diagram of SWR, and I love it because the voltage is normalized and the distance is in the units. What we have here is your transmitter, here is the feed point of your, excuse me one moment, please. Here is the feed point of your antenna, and this is the power going out of your antenna. So the blue is from the transmitter and going out. The magenta is the power that's being reflected back to your transmitter, and the red is the sum of the reflected and the forward power. You might like to see that as an animated version, which is a little prettier. In this case, what we really have is that the this would be to an open. Everything is returned. The blue is what's transmitted, the red is what's reflected, and the black is the composite. He put down SWR does not change with feed line length, but I need to point out something to you, and that is this. That depends. Actually, it depends upon where you measure it. If you have longer feed lines and you're measuring at your transmitter, the measured SWR will go down with a longer feed line. But that has to do with feed line loss. It does not actually affect the SWR at the feed point of your antenna. If you change the length of the feed line, that does affect the impedance of the antenna and the feed line presented to your transmitter. He mentions two cases here. The quarter wave, or actually it's a quarter or any odd multiple thereof, quarter, 3/4, 5/4, so on. It's really interesting. If you have some way of measuring impedance and you have a quarter wavelength bit of coax hanging off of your measurement device, say it's an antenna analyzer, if the far end is open, you will read a short. And if you short the far end, you'll read an open. The other mention that he has is a half wave, and that's actually any multiples for half, full, three halves, and so on. That repeats the impedance at the far end. There's kind of an interesting situation. If you have an antenna with the impedance at the feed point is 50 ohms and your source is 50 ohms, and you have a half wavelength feed line, interestingly enough, it doesn't matter what the impedance of the feed line is. It still matches. It still works beautifully. He does say that radio waves travel at less than the speed of light inside a cable, which is absolutely true. And we call that the velocity factor. What the velocity factor is it's the fraction of speed that light or that a radio wave travels through the cable compared to the speed of light or the speed of a radio wave in a vacuum. So, for example, if you have a velocity factor of 0.84, that means it will travel at 84% of the speed of light. If you're into optics, that same number is also known as the index of refraction. Just thought I'd throw that one out. His next point that he brings up is on feed lines. And what he has is he's going to start off here with coax. And he says coax is convenient to run. Well, why? The big thing is that the electromagnetic field in a coaxial feed line, transmission line, the thing is kept between, and this is really hard to say if you try to say it too fast, the outer skin of the inner conductor and the inner skin of the outer shield, which what it really boils down to is the entire field is contained between the shield and that inner conductor of the coax. In fact, if you have anything on the outer part of the shield, you have what's known as common mode current, which is a bad thing. It's how you get RF back in the shack, among other things. Generally, that's corrected by putting a current choke or some sort of choke on the front, perhaps winding your coax several times into loops near the antenna feed point. Might make that even more powerful choke by winding it through a toroidal core or putting a whole bunch of ferrite beads. he's talking about the many different kinds of coax that are available, and there are many, many kinds. And by the way, even if you buy it from the same manufacturer and exactly the same type, it may not match. There are some pretty significant differences between them that can happen just from quality control. What are those things that identify coax? Well, first off, all transmission lines have a loss. And the way that in coax it's measured is loss in dBs per 100 feet. That's the way you normally buy it. The thing about that loss is it is dependent not only upon the length, but upon the frequency. The higher the frequency, the more the loss. It's quite possible to use one kind of coax on HF, and yes, there'll be some loss, but it's so small that you can tolerate it. But that same coax, if you started using it on UHF, would be very, very bad. The other thing that determines characteristic of coax is how much power can it handle. And that really is mostly based upon the kind of dielectric that's in it and the size. You can generate some pretty hefty voltages on coax, and you can actually punch through some of the insulation. That's why he's talking about a short run of small diameter RG58, which is not what you call low loss. Hey, that'll work for a QRP short run. Who cares about that? But if you're running a tower, say that 100-foot that's going up in Hollywood Hills, I don't know if they're going to use hardline, but I would be surprised if they didn't. Hardline is extremely expensive, but very low loss. Also, it could handle some pretty potent power. The next thing he talks about is twin lead, which is actually all of these twin lead or window line or ladder line. There are two wires that are separated by a dielectric. Very often the dielectric is not a solid dielectric, and I'm going to get into that. Let's see. Twin line is the stuff that we used to use on television sets. It's this flat brown cable with two lines and it's solid, thin solid plastic between them that kept it about half an inch apart. It was rated at 300 ohms. It was really, really cheap. If you got fancier, you could get it with a foam dielectric between the two lines. And I didn't realize this. I actually had to look it up. You can still buy it. It's about $1 a foot, at least on Amazon. I know you've all seen 450 ohm window line. It's wider. If you have a G5RV, I guarantee you've seen it because that's what it's fed with. It's about an inch between the lines. The dielectric is not solid between them. Instead, it has spaces in it, which is why they look like windows. There is also ladder line, which was the amateur's mainstay from 1906 until probably, well, I recall some hams using it when I was a kid back in the 60s, but it was pretty well going out of favor. It is about 6 inches apart between the wires. Originally, it was had spacers made out of wooden slats, and they were separated by about a foot between them, sometimes a foot and a half, just to keep the wires separated. I have seen some articles where hams are making it with acrylic spacers. The whole thing about those is they have considerably lower loss. They are there is very little loss on any of those, particularly on window line or ladder line. The problem with them is trying to get them into your shack. Remember that in coax, the magnetic field, the electromagnetic field is contained between the center conductor and the shield. On ladder line, it's actually contained around the two wires. It's sort of like a donut, which means that if that one of those wires on window line is close to something metallic, whatever that is becomes part of the feed line. So it's a lot more trouble to bring it into the shack. You often end up doing weird things like drilling holes through the wall and inserting ceramic insulators. Now, why would we even worry about all this stuff? And there he goes. He points out that modern solid-state transmitters have a broadband amplifier that don't require tuning. However, they are very, very susceptible to high SWRs, meaning you can fry your finals, which is why he has magic smoke. Certainly, my Yaesu over here won't even transmit if I have an SWR 3-to-1. If I can't get it less than that with the internal tuner, which I honestly don't use, I have an external. Certainly, they start cutting back power. But why? Here comes some more formulas. The maximum voltage on your transmission line is equal to the forward power times the characteristic impedance times the SWR. And then you take the square root of that. So let's take 100 watts, 50 ohm coax, 1.2 to 1. That's 100 times 50 times 1.2. You take square root. 77 volts is the maximum voltage along that transmission line. Let's change the SWR to 5-to-1. And that's example 2. And suddenly you are at 353 volts. This is not really good on transistor finals. The old tube rigs, they did a better job. They could tolerate almost anything, which is one reason why SWR was kind of ignored until they started having more and more transistor finals, because they could load up almost anything with a tube rig and finally get it to tune. What you're seeing there is a pi network. You have two variable capacitors and a variable inductor, although a lot of times the variable inductor actually was a tapped coil. That was the output of your tube rig. If you look at the current QST and their remember when pages or whatever, they have a junk box 500 watt linear amplifier using an 813. And if you look at the output of that tube, what you're going to see is a pi network. That was a very interesting article, but I do have to wonder about the comment that they assumed that you could just go find a 800 volt transformer in your junk box. You might find it in Ray's. You're not going to find it in mine. I don't have anything close to that. By the way, this is also the same kind of circuit that is inside an antenna tuner. It's just separated from the transmitter. Most of the time, they do not use pi networks. Most of the time, most tuners these days, you use T networks. A T network that's commonly used would have the arms of the T would be the variable capacitors, and the coil would go from the center where those capacitors connect down to ground. One reason that T networks are used rather than a pi is a T network with common components can adapt to a much wider range of impedances. So you got more place to correct. The reason that you see a pi network and all those old tube things is because this is a low-pass filter. And let's be honest, those old tube amplifiers may not have had the cleanest output that you can imagine. This helped keep it that way. So what's the other reason for worrying about this nonsense? Well, how about the signal that doesn't actually make it out the antenna? Remember, I said that the signal goes, your power goes from the transmitter to the antenna. Part of it is accepted by the antenna and is radiated. Sometimes, if your SWR is not exactly 1-to-1, part of it goes back to the transceiver. Now, making the trip from the transmitter to the antenna, you're going to have some line loss. Let's say you have a dB, which is not unusual. So you lose 1 dB going from the transmitter to the antenna. Now, that reflected power has to go back over that same line. So it gets another dB. That's another dB loss. When it hits the transmitter, it's reflected back. And it goes back to the antenna, where part of it is accepted for radiation, but it still has to go through that same line. So you're still going to get another dB loss. That's 3 dB loss. 3 dB loss is half your power. It's not as bad as it sounds when I say half your power, because really 3 dB loss is about half an S unit. And I'm going to stop for a moment to ask if there are any questions.
Haven't seen any on the YouTube yet.
Have we had everybody leave yet? I can't see because I'm presenting.
Nope, looking good. We got 20 people in the live chat and 19 on YouTube.
Well, let me keep on going. The next thing I'm going to touch on is some slides that I threw in, because Terry pointed out a program in an email after he prepared his slide deck. So I'm going to give you some really basic run through here, which 90% of you know, but maybe somebody doesn't. So let's go ahead and do this. Resistance. Resistance limits current flow. Resistance is not dependent upon frequency. So a 100 ohm resistor, and by the way, I got to stop here for a second. When I'm talking about a resistor, I'm talking about the one that really doesn't exist, and that is to say it's pure resistance. It doesn't have any inductance. It doesn't have any capacitance, and real components aren't like that. So, but when I'm saying resistance or capacitance or whatever, I'm talking about the ideal ones. So a 100 ohm ideal resistor is 100 ohms at DC and at 1.2 gig. Doesn't matter. A resistor never changes the phase of the voltage to the current. And it really works by converting electrical energy into heat. Somebody pointed out apparently the most efficient invention we've ever had is an electric heater, because even its loss is heat. And of course, in our formulas, we mark it as R, and it's measured in ohms. Anybody know what the reverse of measuring that what's called conductance, other than just the inverse of resistance? These days, it's called Siemens, after a German engineer. But what it used to be called was Mohs, M-H-O. I thought that was a lot more enjoyable than some German engineer. Reactance is found in capacitance and inductance. Reactance also limits the current flow, although it tends to limit current flow that is changing. Reactance is certainly very frequency dependent. Capacitor with DC, which is a frequency of 0, is an infinite ohms. An inductor with DC has 0. It does change the phase between the current and voltage. Capacitance, I'll do this backwards because I always do it. I think capacitance leads and inductance lags. Yeah. And it can go up to 90 degrees phase difference. It does change the current flow into a different kind of energy, but not heat, but it stores it. So it becomes an electrostatic field for a capacitor and a magnetic field for an inductor. It really just stores it, and it will be returned, says the guy that was holding on to the Model T coil while his friend disconnected the dry cell. I guarantee it gets returned. In formulas, it's marked as an X, and it's also measured in ohms. And now we're going to get to the nasty part, impedance. Impedance is both resistive and reactive. It's resistance and reactance do not mix. They're like oil and water. In our formulas, impedance is shown with the letter Z, but it's also measured in ohms. But it's actually a complex number, R plus or minus little jx. Okay, R is resistance, the X is reactance, and J is the square root of -1. Now, if you remember your handy-dandy high school algebra, you'll remember that we always used I as the square root of -1, and it was a imaginary number. But we already use I for current, so we move to J. This makes mathematicians develop tics or sneer. It just makes them nuts. The sign before that X there, the plus or minus, that denotes whether it is inductive or capacitive reactance. Inductive is positive, capacitive is negative. And although I'm not going to go into the math about how antenna tuners work, if you stop and think for just a second, there's a little hint there. Suppose you have inductive reactance that you want to cancel. Well, you add the equivalent in capacitive reactance, which is a minus, and they cancel out. Yeah, you can get what's called the magnitude by using Pythagorean's theorem, and that is to say you take the square of, or you take the sum of r squared and x squared, and you take the square root of that, and life is that. Why am I going through all this nonsense? I wanted to introduce you to this idea of that J when it comes to what we're talking about for impedance. That's because I'm going to bring up another program. This is called Transmission Line for Windows, and this is what Terry in his email wrote about. I'm just going to slip it up. It's if you get the ARRL antenna book, it's included in the downloads. It's free. It's for Windows only, as far as I know, but I think it runs fine if you run one of the, like Parallels or something like that. And I believe it even runs under Wine for Linux. You can get it off the web, but I think he's charging money for it. You can also find a whole bunch of other calculators that give you exactly the same sort of information, but I'm lazy and already had this one. I didn't have to pay any money for it. So let me go ahead and start it up. And I'm doing this because I'm going to show you what happens with feedline loss and SWR. And I blacked that out because now I need to actually start up the program. Can everybody see that?
Yes.
Yep,
Thank
looks
you.
good.
Oh, it just disappeared. Let me bring it back up. Actually, what I have to do is turn off my laser pointer. There we are. Hey, looky. Isn't that cute? Let me show you what's here. The top is the kind of feed line that you have, the length, and you can cheat and put in a W for wavelength, so you can say 0.25 for a quarter wave. Obviously, the drop down that does let you build your own, but you can put in like RG8X. And you notice he's listing times microwave and Belden. That's because they're slightly different. This is the frequency that we're interested in, 21 megahertz. I can put anything I want. The characteristic impedance of this feed line is 50. Hey, there's our R, minus J, 0.39 ohms. The minus means it's capacitive, and that 0.39 is so ridiculous it's not even there. This is the loss. It's a little over a dB per 100 feet. The velocity factor is 0.84. The maximum voltage is what it's rated for, 300 volts. If you go higher than 300, you might have a problem. And then he's talking about total match line loss, which I'm not even going to begin to get into at this moment. Now, we have a source, which is normal. I'm not going to go into the Autek or noise bridge. Let me just say source normal is perfectly fine. It's your transmitter. Load is 50 ohms. The reactance is 50. Boy, is that beautifully matched. And if we look down below here, you can see that the SWR at the line input, which means that the transmitter, is 1.01, which happens to be the same at the load. Don't worry about rho. That happens to be the magnitude of the return loss, gamma. Additional loss, nothing. Total line loss, well, there it is, because I put in 30.91 feet, so it's that. The impedance of the input is 49.86. How close is that to 50? Minus kin capacity of 72 ohms, and there it is right there. Oh, this one is actually Cartesian coordinates. This is polar. I'm not even going to touch that. I'm going to be kind. But let's get nasty. Let's put in a 72 ohm for a dipole. That's fairly close to a lot of dipoles that are reasonably high up. But we're going to make the dipole very, very short, which means that it is not going to be resonating at our 21 megahertz. And in fact, we're going to give it 500, minus 500, so it's capacitive, ohms. And if we look, all of a sudden, the SWR goes up to 18.74. But I want you to see something. The SWR at the load is 67.85. That's one heck of an SWR. I'm going to graph this. This is the resistance and reactance from the transmitter. Oh, is that ugly? This is the current, and I hit the voltage. I meant to hit something else. Well, we'll leave it there. That is the maximum voltage is almost 1200 volts, and that coax is rated at 12 or at 300 volts maximum. You're going to be arcing, shall we say, some. That is a really nasty thing. Let's see if I get the right one this time. Oh, there we are. That's how the voltage and current changes along your line. You want to make a match? Actually, this has a nice little button. Let me close this down. Nice little button there. And it says, well, actually, it doesn't tell me. I'm going to use a T network. And there is my T network. See, there's my two capacitors and my coil. And the values that I need is 35.9 picofarads, 100 picofarads, and 0.35 microhenries with some straight capacitance. So see, it'll actually give you that sort of nonsense. But what's really important that I want to bring out is the SWR to the line input's there, and at the load, it's considerably higher. That's why I was disputing this business about it's constant, doesn't matter. Oh, let me do one thing here. Let me change that to 100 feet. And suddenly, look at our SWR at 7.2. Let's give it 1,000. Boy, 1,000 feet. That you could match with almost any transceiver out there. If you see, at the input, it's 1.17. Why is it doing this? Remember, I was showing you the line loss as it came back. And the way we're measuring at our transmitter with our SWR meter is the power going out and the power coming back. The power going out is right there at the transmitter. Boy, we got everything full there. Power coming back is what made it out the feed line, gets reflected. You got two passes of the same line loss, which is pretty potent, 10 dB for 1,000 feet. That is enough to affect the power return, so it makes the SWR look much, much smaller. However, let's go in and put in a 7/8 inch 50 ohm hard line. Our losses are considerably different. If you want to see really bad, believe about 174. There you are. How about a loss of 53 dB? Oh, and it's that's not a good thing. Let me get out of this. And of course, I would hit the wrong button, and we'll start here. That's the point I was trying to make, and he was suggesting using that program for STBR. Usually looks better when measured in the shack than it actually is at the antenna. In fact, I'm not going to say usually. I'm going to say always. Moving on. Most modern rigs do have a tuner inside that'll do at least 3 to 1. And so they can handle a reasonable range of mismatch. Where this really comes in handy, I don't suppose anybody here is using anything other than a compromised antenna for 80 meters. Some of us are using, for example, verticals with loading coil. And one thing that you notice about the compromised antennas, that is to say, the shortened antennas, is that the range of resonance is pretty narrow, meaning they're very high Q. So the range of a low SWR is also narrow. Well, let's be honest, the 80 meter band is incredibly wide. So you either manage to get the thing resonant for the CW, or for most people, the FT8 side, or the phone side, but never both of them. If you look at the 80 meter antenna at W1AW, in order to make it flatter over the entire band, the antenna is actually composed of 4 branches that are held about 3 feet apart with a set of crosses, so that the radiating element is electrically bigger diameter, which increases the bandwidth. Another thing that you might want to use that, even though you have a very nicely resonant antenna, is depending upon things like ground conductivity, the bird sitting on it, the tree, if you are in a wooded area that's growing up beside it, all sorts of things can affect how the impedance of the antenna. And a nice little simple tuner in your radio does that very well. Some manufacturers, like Paul's new favorite, Elecraft, have internal tuners that can do a very wide range. In fact, I have the poor man's version. I have a Shegu G90, and it will. I think I could tune acceptably a aluminum lawn chair. It'd be a lousy antenna, but I think I can get the SWR on it down low enough. Very often you find this on portable rigs, because it's people that tend to do things like throw long wires over trees, and heavens only knows what the SWR resonance and other characteristics are. Very important. Don't use the internal and the external, if you have one, at the same time. One or the other, not both. You're going to drive yourself nuts. Let's talk about some tuner fundamentals. External tuners vary in features, price, size, and convenience. Isn't that true of about everything in life? Manual tuners, yeah, you have to sit there and adjust them every darn time. Like I'm hoping that Wally is on, because he's got a manual tuner he's just been working with, and yeah, you got to sit there and adjust it. Automatic tuners have a microprocessor in them. Let me explain what's going on here. Manual tuners will have variable capacitors, like we've all seen, and a variable inductor. It could be, I've seen some really old ones that the coil was tapped and it had a 700 position rotary switch to pick the tap. Obviously, it's better to have a roller inductor, which is a coil that has a wiper that moves along the coil to select what it is. The automatic tuners, they have fixed capacitors and fixed inductors and a whole bunch of relays and a microprocessor to flip the relays, so they can bring in different combinations of capacitance and inductance. And then they have measurement on the SWR, so that they can select, and they have very good algorithms to say, oh, well, it's moving this way, let me do that. They are wonderful. I'm sorry, but they're wonderful. On the other hand, they're a lot more money, particularly if you're talking about high power. Automatic tuners for high power get very expensive, mainly because things like those relays get very expensive. There's also a remote tuner, and I have one. It's a Yaesu. What it is it's an automatic tuner, but it is designed to fit right out on the mast that's holding a random length long wire. So you don't have to worry about feed line, because it's actually matching right directly at the feed point. So you don't have to worry about all those losses. The problem, obviously, with something like that is you have one antenna on it. You can't go swapping it around like we do. Manual tuners are going to require some way of displaying the SWR. They'll either be internal, or you're going to use the SWR meter external, or you're going to be Paul and grab the bird watt meter. But there's going to be some way that you're going to have to measure the SWR. And there are all sorts of techniques on the manuals. Very often the manuals, you do things like set the maximum capacitance and the maximum inductance, and then start cranking back on the inductor until you get a lower SWR. But if you don't see that, then you start moving the inductance back up, and you start reducing the capacitance by that amount, by like 10%, and do the same thing and keep doing that. And then you try it with both capacitors, and I love automatic tuners. What Wally did is the really sneaky way, and probably the best way. He used an antenna analyzer, and that will match just as well as anything else. Automatic tuners, they don't really need to display. My Elecraft has, I think, 5 LEDs. I've got an MFJ that has a little bar graph. You don't need much. What you have to be aware of when you're buying a antenna tuner is its power handling capability. Remember those big voltages and that square root and all that other stuff. You start kicking up the power, you're going to kick up, if it's mistuned, the amount of maximum voltages. Terry goes into talking about the peak envelope power, and he's saying modes like SSB have peak envelope power approximately 4 times higher than continuous modes, but that is because the duty cycle of the modulating waveform is very low. You have to be careful. If you're using digital modes, the sound card modes, or RIDI, using a sound card to generate it, the duty cycle on those things is real high. And so you put out a lot, you're putting much more stress on the transmitter when you're doing digital than you are when you're just simply talking. Even if you crank up the compression on your phone, you're still doing more. Obviously with FM, it's just a full power in DC. And if you are crazy enough to do AM, which I think only Bob Heil does anymore, that's why if you have a 100-watt transceiver, what it boils down to is the total power is roughly equal to 4 times the carrier, which is why when you put it on AM, you get 25 watts out with the carrier. Frequency range, yeah. Big ones start having the physically bigger antenna tuners start having problems with things like straight capacitance and so on. Some of the tuners do not go, for example, to 6 meters. They'll go up to 10. And again, if you buy one that has a lot of power handling capability, you're going to run into the same problem. More power, bigger components, more of everything else. So what he's telling you is to match the tuner to your specific needs. And then he has a note which into SRK blessed. It is bad form to tune over another station or a pile up. Please move away from an in-use frequency, or to an in-use, from an in-use when you're just in your tuner. And that's also true if you're using digital modes like FT8 or JS8 call or PSK1, PSK31. It is incredibly frustrating to suddenly hear somebody tuning up right in the middle of the band. And there's no reason to do that. How are you going to adjust it? Well, read the fine manual. That's RTFM. Ray may know it with a slightly different set of words. Yeah, use the manufacturer, and always use the lowest amount of power. With manuals, you can really get very low. With automatics, there's a certain amount of power that's necessary so that it has a sensing that will trigger all the tuning operation. But it's generally like 1 or 2 watts. It's very small. Also, a lot of the automatic tuners have the ability to add a cable that will communicate with your transceiver. Like the MFJ that I have, you can buy a cable for a Yaesu or an ICOM, or I think a Kenwood. And the transceiver puts out all the information about what frequencies it's on. When you change bands, it will tell the tuner, so it can automatically adjust. And if you've tuned up on a frequency before, it generally stores that information in its memory, so that when you go back to that frequency, then it will make a real quick run at it. It doesn't have to go through a full tuning cycle. It's much, much faster, and you don't have to hear so many relays clicking. The memories on tuners vary all over the place, how many you can handle, but generally speaking, you're going to be doing great. The thing about manual tuners, you have to do what Wally did, and that is you have to mark everything beforehand so that you can get back to it. When you're using a power amplifier there at the antenna end, and I had to stop here for just 1 second to say this, so everybody, there is absolutely no question. The order is transmitter, amplifier if you got it, tuner if you got it, SWR meter if you got it, antenna. Don't get the orders mixed up. Your amplifier and frankly your SWR meter, or your tuner rather, are all designed for 50 ohm nominal impedance. So you can use reasonably short cables that are 50 ohm. You don't have to worry about a mismatch because the source is 50, the load is 50, the cable's 50, everything's 50, you're all good. It's from the tuner on that you really have to worry. Also remember that a tube amplifier's output, I think most people are using tube linears these days because of price. They can handle a lot wider range of mismatch than any kind of solid state. But you can still fry them, which unfortunately some people have found out. That's his favorite tuner. You'll never guess that he does QRP, would you? That is a T network. And what you're seeing, and I will turn on my laser pointer again. What you're seeing is this is from the radio. It's a BNC. This is going out to a coax. This one is for a balanced antenna, but I believe also you can flip a switch and just run a long random length off of this one and run that to ground. This is the capacitors that you're going to run. This one right here removes additional capacitance. And I guess I take that back. That must be an L network because that must be a capacitor and a coil. I don't know it. It's $62.50 and sounds like fun. And then he's going to drive you insane with a 150-foot doublet at 75 feet, fed with low-loss window line. He says that'll outperform a 7-foot tall mobile with a radial. Oh, no, that can't be. I wish I had the ability to have a 150-foot doublet at 75 feet high. I'm jealous if he has that. And he may. What can I say? The thing is, a tuner can help you get out. Do not obsess over the SWR. I know, talked about it a lot. But frankly, that's the least of your problems. The most important thing to do is not worry about your SWR, but actually get on the radio. And as long as you aren't driving your finals totally nuts, go out and make some contacts. That is the right way to practice ham radio. Finally, he's got 2 books. I have never read the Guide to Antenna Tuners. I have never seen it, but it sounds interesting. However, I cheat and use automatic and don't build them, so I don't care. However, I cannot more strongly recommend the antenna book. That is, if you haven't gone out, I think it's about $50 now. I think it's a 4-volume is what you want. It's a lot more convenient if you have it in 4 volumes. It's easier to hold. If you want to know anything about antennas or tuners or anything else, that is the book. You do not have to buy it every year. Even when it changes, frankly, they last for years and years. Please, for your own sake, go grab one. And his final slide is enjoy our most amazing hobby. And he's saying 73 from Whiskey Bravo 3 Echo Victor Zulu, because I cannot say EVZ without doing damage to myself. and of course, Paul AC5S on the Elmer committee. That ends the presentation. Thank you very much, and I will quit presenting.
Excellent. Excellent, Tom.
Thank you,
Very,
thank you.
very good. Wow. Outstanding. Exciting stuff. Let me throw it over to Wayne and see if we have some questions that came in on YouTube, Wayne, or anything there? Any questions there? There he's back. Wayne, any questions for Tom that came in on YouTube?
No, not that I see. It's been pretty open. I was just opening up the presentation to everybody. But no, I don't see anything as of yet.
Well, let's get some questions going here. So not everybody at one time, but let's see if we can get a few questions from either side, either the Google Meets or from YouTube. So we'll kind of see how this all works. Questions, come now.
Looking here. I know he had mentioned about the auto tuners having an internal tuner and an external tuner. I know I've heard hams talk about that and why that's not a good idea. Tom, would you like to elaborate on that?
Actually, with an internal and an automatic external tuner, it probably isn't that big a deal because the input impedance of the automatic and tuner is going to be 50 ohms with 0 ohms reactance. That's the way they're designed. So if you hit the automatic tuner, all you're going to do is tune to 50. You're not doing yourself any harm. You're not doing yourself any good. Where it comes nasty is if you use something like a manual tuner, like a Pi or a T network, then you're starting to introduce problems on you're trying to transform between two impedances that don't necessarily match. It's not stuck at 50 ohms on the input side in that situation. So that's why you want to avoid that. And it doesn't do you any good. Why are you doing it anyhow?
Right.
Does that answer your question?
Yeah. No, I just had some, I remember some people asking about that. I thought I'd throw that out there. We did have a question come up on YouTube. What's the craziest antenna that you've seen work well? And I guess I could open that up to everyone. So I know we've had some people in the group tune up some gutters. Ray, what's the most interesting thing you've tuned?
Why me, man? Am I? Oh, what have I tuned? I'll attempt to tune anything that's metal, but typically, rain gutters. I did those. They transmit real well, but mine in particular are noisy. On receive, it was like 10 over. It was terrible, but they were seeing me on PSK reporter just a couple of watts on a digital mode.
Oh wow!
I wasn't going to run power into the gutters. I figured that would be bad. I've tuned up other just random bits of metal laying around. I had the railing out of my old house, for instance. I had leaning up against the fence in the backyard, and it loaded up. I didn't make any QSOs on it, but I found a match. Oh,
okay.
I walked up to a guy who he had a big box trailer, and he found the sweet spot where he attached just a piece of line, like an end-fed kind of wire antenna, just the right spot on the fender. The trailer just happened to be resonant on 40. He didn't even need a tuner. So
nice.
That wasn't me. That's just a story I heard, but I believe the guy. So
yeah. Now the ham radio was a ham radio crash course guy on YouTube. For Christmas, he ran a set of Christmas lights as a dipole off of his hex beam, and was pushing power on it where the actual bulbs were lighting up when he transmitted. And he's also done camping chairs. He's used as an antenna. But beyond that,
Isn't that the one where you hang it off the eaves? And was
Yeah.
that way, yeah.
Yeah.
It's a man after Ray's own heart.
Right. Yeah, I haven't done too much craziness, besides just throwing some wires in the air.
Hey, Tom, do you want to make any comments about the, I know you go to HRO if you're a new HF ham, and you talk to them, and no disrespect to HRO, because they try to sell something that they believe is going to work in every situation, but a lot of times they'll sell the G5 RV and G5 RV Junior. You want to make any comment about about miracle antennas that claim to work on all bands with no tuner?
Yeah, I'll talk about that. Although Doug will come and throw things at me because I think he has a G5 RV. There is no such thing as a miracle antenna. I'm sorry, it does not exist. But people have been promising that for years. Frankly, I think your best starter antenna, if you've got space, is a nice, simple dipole. I think you're going to do better than that than you are with anything else. And you can start getting dual band. MSJ puts out a little, I think, tri-band dipole that the cost on it is about $80. And that is going to get you up on 40 and 20 and I think 15. So it might be 10. But that's the way to go. The thing about from people that I have talked to that have used the G5 RV, some of them love it. I mean, it's the best antenna that they have ever had in their life, and it works wonderfully. But most people I've talked to say that you have to have a tuner. It is not all band, and while it works, it doesn't work any better than a dipole.
Well, I think the most important thing that you said there is that there's no magic antenna, and the verticals that are listed as no tune verticals, multi-band, no tune this, no tune that. I think you're right. The best antenna probably for if you're around the house all day and you can get on the air during the day, put up a single band 20-meter dipole. And if you're on the radio at night, then you can't beat a single band 40-meter dipole. These antennas are going to work exceptionally well, and but just those comments are important. I think a lot of people think that they can buy an antenna that does every band and no tuner needed. It's just not there. Now, if you are going to buy a G5 RV, then follow the instructions on setting it up. Get it at the right height.
Yep.
Absolutely at the right height. Don't have it hanging 6 inches off your siding on the side of the house. And that's where a lot of people on some of these miracle antennas, they are trying to do more than what can actually work with the laws of physics. So we have a lot of experience in the club. A lot of experience. If you're new to HF and you want us to come by and help you with an antenna design, Terry, Ray, Wayne, I mean, I can list a lot of people. I'll list those people right up front because they're probably some of the best people we have. But we're happy to come out. We're happy to come out, survey your situation, and make a recommendation for you based on the time that you operate and the band that you want to operate. And we've come up with some pretty darn good designs for stealth antennas as well for people in Highlands Ranch and different places. Just a quick story. Everyone knows, well, I won't use any names here, but basically Ralph, we all know Ralph. And, we helped Ralph put up a stealth antenna, a wire antenna in his backyard. And every time I go to Ralph's house, I turn the corner, look at his house, try to see the antenna that I helped him put up, and you can't see it. You just can't see it. And he uses that antenna for multiple bands, and he does a really good job with that. So if you are in an HOA, and you probably are going to have to put up some type of compromised antenna, and you're probably going to need one of these devices that Tom's been talking about, which is a tuner. So, give us a call, drop us a note on the email, and we'll be happy to, Ray and I will probably show up one afternoon, and we'll help you get something designed. Back to you, Wayne. Any other questions came across?
No, nothing new. Nothing new as of yet.
Well, the exciting thing is that Randy blew up his linear, and he's getting help in the chat room from that. So Ray is helping him. So I guarantee you do get help. Although I do have to worry about.
Now, wait a minute. I was tuning it, and it blew up. by the numbers in the manual.
Well, if you're tuning it with 65 watts, Randy, it's going to do something wrong.
No, I was tuning it with zero.
Yeah, how much power were you running into it when you were tuning?
Zero.
Well, you got to give it some power.
Well, yeah, I know. I was giving it some power, and then I turned it up to, I think, 20 or something like that. And then I was sitting here, and then it started going buzzing. And the next thing I know, no smoke.
Did it start buzzing and making a vibrating kind of noise without any drive?
Yeah, I was doing that too. So I think it was arcing.
I bet one of the tubes went into oscillation.
Mm.
The early 811s had a different protect circuit. The parasitic oscillator protect, where the tubes come together, it shunts all the shit to ground so it won't go into self-oscillation on you. That amp doesn't have any of those protections they put in the later ones. So if you had a tube that was a little shitty, it might have started oscillating on its own and blown up.
Well, certainly possible. It was a match set. I mean, it was a replacement, but there could be something else going on in there too.
Well, were they brand new tubes?
Brand new.
And untested, you'd never used them before?
No, they were supposedly a match set, so I assume somebody along the line tested them.
Match set from who? Ameritron?
I'm sorry?
Who'd you buy them from?
HRO.
Okay, were they Ameritron branded tubes?
No, they were something else. That they had. They only had a set of three, and that was it.
Yeah, because Ameritron's idea of a match set means they all said 811 on them. So
right. That's a match set.
They all looked the same. They were all better than the ones that were broken.
Yep, these are 3 tubes.
All right, well, if you want to dig in and play with it, I highly encourage that. I find fixing amplifiers the coolest part of the hobby. I like finding broken ones and fixing them.
Oh, I'd be more than happy to bring it over to your house and drop it off.
Yeah, I'm happy to dig into it too, but I don't want to steal your thunder. If you want to dig in and start poking around in there, just make sure that high voltage needle is all the way this way before you do anything.
Well, yeah, both needles are pretty much right there now anyway. Even on when it went to high voltage, when I tested it a minute ago, it was up, then it went right back down.
Well, yeah, okay. So the safety resistors are working. Those are good too. So
yeah.
That sounds like the transformer's good. So
yeah.
It does nice switching. All the lights light up. It's great.
Well, that's fantastic.
Right after you
we'll fix it.
Right after you turn it off, lick your fingers and find the high capacity, the big capacitor in there, and that will prove that capacitors do store energy. And I guarantee you won't worry about it again.
I know better than that from high school electronics.
Okay. Here, you want to lick?
Oh yeah.
Well, doesn't everybody have a box of large capacitors laying around?
Sure. Well, it's been really a lot of fun here tonight. If we have additional questions, we'll throw them Tom's way. If not, we'll see if there's any other business that we need to cover. And I did talk to Dan a minute ago. He said to tell everyone hello. He's tied up with something at work. So he may jump on here at some point. So I'll ask one more time. Any additional questions for Tom? Okay, well then how about any additional questions?
There was a question that popped up asking.
Okay.
It was in YouTube, in the Google Meets. Do tuners help with receive?
Yes, but not that much.
Okay.
Okay, why?
Yes, obviously, if you're trying to match the impedance, you're going to have better power transfer. So yes, it does help, and you can use it's not specifically a tuner like I've been talking about, but think about a magnetic loop antenna that has an extremely narrow bandwidth on them, as we're seeing Wayne nodding his head because he probably owns one. And the way you tune that sucker is you tune it for maximum noise first and then go from there. Isn't that not true, sir?
Yeah, absolutely.
But
and it's pretty close. It's pretty close.
Oh, it tends to be.
Yeah.
But to be honest with you, there's way too much emphasis upon SWR because the amount of loss that you're going to get from a mismatch on the receive side is comparatively small. No, yeah, you're going to lose some if it's not perfectly matched, but the amount you're actually really, truly going to get hit is comparatively small. It's more important going the other direction to protect your own equipment. Does that answer does that give you an answer, Ray?
Well, that was Kevin K0ROK that posted that in the chat. The only other question, he said, yep, he's good. The only other question that I have, is an SWR more important with QRP than with 100 watts?
Yeah, because you're putting out lower power to start with. So you need to get everything that you can out there.
Try to get it perfect.
Yeah, but remember SWR, I mean, I gave that thing with the 3 dB loss and it's half your power. That's still half of an S unit. S units are traditionally 6 dB apart.
Mm-hmm.
It's going to impact, sure. But is it going to be that big a deal? I'm thinking I have a wonderful little whisper transmitter here that I got from Dan. I think it's 200 milliwatts. I'm regularly, when I have it running on the end-fed half wave out here, which I do real regularly, I'm getting 8,000, 9,000 miles out of that. 200 milliwatts? There's more things that are impacting your propagation than how much power you're really shoving out that antenna.
Right.
However, I will say this, a lot of people over the years that I have that do a lot of QRP, they will only use resonant antennas. I mean, it's to maximize your power output, and especially if you're operating QRP on some of the frequencies that are designated for QRP. If you always know you're going to operate on those frequencies, you can build an antenna that's going to be 1-to-1 on those frequencies, and with the exception of KX2s, KX3s, or the 5105 that Tom has that has a built-in tuner, if you are using some of the radios like Terry takes out in the field, and you're using a resonant antenna where you don't need a tuner, that's just less weight.
Yep.
So even though that little tuner you showed that he had is small and light, if you really, really, really want to make sure you get the maximum power out, just build an antenna that's resonant and operate on that same frequency every time, and you'll be good to go.
Nice.
And I will be right back because there's something I want to read you.
Sweet. No other questions on YouTube Live. Any questions to the 19 people on the Google Meet? It is Elmer night. Any questions?
So I've got a question. Wayne, I've got a question.
Go ahead.
It's a little bit off the subject, but do we have any upgrades? Anybody have any license upgrades that they'd like to share with us tonight?
I don't see any online as of, well, it probably hasn't transmitted on YouTube Live yet.
If I could give you something, I ran across this last night because I was looking up something else. And you might recognize that this is the ARRL handbook for 2020. A third, and perhaps even more prevalent myth, is that you can't get out if the SWR on your transmission line is higher than 1.5 to 1 or 2 to 1 or some other such arbitrary figure. On the HF bands, if you use the reasonable lengths of good coaxial cable, or better yet, open wire, ladder line, the truth is you need not be overly concerned if the load is kept below 6 to 1. This sounds pretty radical to some amateurs who have heard horror stories that if you load up your transmitter without any arcing inside, or if you use a tuner to make sure your transmitter is operating in its rated load resistance, you can enjoy a very effective station. Yet time and again, this antenna, for example, a 450 ohm open wire line connected to the multiband dipole. Does that sound like a G5RV? In previous actions would have had a 19 to 1 SWR, yet time and again, this antenna has proven to be a great performer in many installations. And the final sentence is, fortunately or unfortunately, SWR is one of the few antenna and transmission line parameters easily measured by the average radio amateur. Ease of measurement does not mean that a low SWR should become an end unto itself. The hours spent in pruning an antenna could be used in far more rewarding ways, making contacts, for example. And that's the official ARRL stance. I thought that was interesting.
Well, what they're saying there, Tom, is that you have a high SWR and your radio rolls back its power from 100 to 50 watts, you can still probably make all the contacts you want on 50 watts because there's really not that much difference between 50 watts and 100 watts, right?
Absolutely.
So as Dan would say if he was here, just get some wire in the air and get on the air, right?
Amen.
Yeah, there was a general, Chris Gardner, which is on the YouTube Live side, said he got his general. So congrats.
Yes, sir.
See you on HF, buddy. And the club does have 2 loaner radios. I think they're currently both loaned out at the time being. But we do try to cycle them every 30 days. So feel free to reach out to Justin, AE2L@parkerradio.org, if you're interested in borrowing one of the club radios.
And we typically loan those out for 30 days unless there's a lot of people in line. So right now they're both loaned out, but they'll be back in here in a few weeks. And if you want to borrow one of them, they're both fantastic radios. 991A by Yaesu and the 7300 by ICOM. They're totally different radios. I think yeah, everyone
absolutely.
Absolutely. And so, but they're both fun in different ways. So try them both. Don't just try one of them. Get the 991 and then get the 7300 later on.
Yeah, and those are both the go-to, I would say, beginner radios. So if you're looking to purchase a radio, it gives you a chance to use it, check them out before you actually go and buy one for your own chat. So.
Well, see, if I were to loan it out or if I were to have it at my house, I wouldn't want to give it back. So I'm going to refrain.
Yeah, I actually won the Colorado QSO party with the Club 7300 the first year. So.
Nice.
Yeah, it's a nice radio. And another thing to add, the club also always, at least once a month, we have an outing where we go out and play radio. And, you know, anyone's welcome to come out, take a look at people's setups, what we have out there. I try to get out, do a soda activation at least once a weekend. And, you know, and there's quite a few other people. So, yeah, if you're new into the hobby, just get your license. Feel free to reach out to the club. There's always someone somewhere that's, you know, more than happy to say, you know, come check out what I'm doing.
And speaking of that, August the 22nd is our next outing, and we're going to be going up to Teller County. And we're going to be going to a little hike that we call Signal Butte. Actually, the little peak is called Signal Butte. And it's about an hour and 45-minute drive out there in the Heyman Burn area, actually. It's a beautiful area. And we're going to hike up to the top of Signal Butte and take all of our equipment with us. And at the top, we're going to set up antennas and work the world. So a couple notes on that. First of all, we'll be leaving fairly early, and the meet point is Parker United Methodist Church on Parker Road in Parker, and I'll be getting some information out to Elizabeth here in another week or so with these specifics. We're going to take a drive out there, and then it's about a 30, maybe 40-minute hike up to the top of the peak. I will say it is somewhat strenuous. There are some stair steps and some switchbacks, but it's not a long hike. Let's put it that way. And when you get to the top, you'll have a 360-degree view of the Heyman Burn area, and it is absolutely fantastic. There are some old dead trees to hook up antennas on, and there's some large rocks that we can set up some shelter from the sun. And the only thing we're going to be concerned about as we get later into the day are thunderstorms. So we're going to get there early and try to make as many contacts as possible through about the noon hour, maybe a little later, and then head down to Colorado Springs to Rudy's Barbecue and have a little barbecue. Ray just smiled when I said that. So good barbecue and good friends, good camaraderie. So if you want to make that trip, you don't have to sign up for it or anything of that nature. All you have to do, and there's a picture from the top of Signal Butte, and it's a fantastic trip. We did this last year, made a lot of contacts, and we expect to make more this year. So you don't have to bring a radio. You don't have to, you can just come along and check out what everybody else is doing, or you can bring a radio and an antenna or an amplifier or whatever you want, as long as you can bring it up the hill. And there's John working his 817, making contacts. And let's see on the next slide.
Yeah, KX3 there at his foot. That was, it was good times.
Yep. And there we are on the way back down. And what a fantastic trip. So come join us on August the 22nd. We will get some more detailed information out on the blasts here, and probably not this Sunday, but the following Sunday and the following Sunday after that. We'll give you some detailed information on that, and we hope you can all join us because it's going to be a fantastic trip. The more, the merrier. Back to you, Wayne, and we're going to shut it down here pretty quick if we don't have any additional questions or comments.
Can I add something? Can I add something?
Go ahead.
Absolutely.
Don't bring an amplifier. That's all I had to say.
Oh man,
Why
you're
not?
not bringing your 811.
So I'm going to make a comment about that. We all made it to the top last year, but nobody had more equipment than Randy did.
Yeah.
And he had everything, and that's not a bad thing. That's a good thing. But in his pack, in his box of goodies, he actually had an HF amplifier. and I was impressed. I don't know that he got it going, but it was pretty impressive anyway. And I think, Ray, you're now the proud owner of that amplifier. Am I correct?
Yes, sir. I'm going to attach it to my lunchbox.
Okay.
Oh, nice.
All right.
Yeah, but if I remember correctly, didn't Terry bring up all of his equipment? Wasn't that last? What?
Pulling my radio with the amplifier.
Right. But
I
it's
think-
always it's a good time. It's always a lot of fun. It is a strenuous hike, but it's a decent summit, and it is actually classified as a summit on the air summit, so we can set up the alert and have chasers looking for us, and we'll get that all going.
So I didn't bring a radio last year. You guys may remember that. I didn't bring a radio. I just watched everybody else do their thing, right? So who made the most contacts last year, Wayne? Was that you? You're usually the...
I was thinking it was me or John.
Yeah.
I think we're the most.
And Ralph did pretty good too.
Yep.
Yeah.
Yeah, it was pretty good. I think we probably had 30 or 40, I would say.
Yeah, it was amazing. It was really good. I think there was a West Coast QSO party.
Yeah.
If I remember right, we were working the West Coast really, really well.
And it looks like the hike round trip is a mile. The elevation gain is 547 feet, so not too bad. And the summit is roughly about 9,350 feet. So not too bad.
I think that the hike back down was harder than the hike up. That's me.
You're right, Elizabeth. It was. It's always
watch
hard. It's always hard on a person's knees coming down. It's a pretty good hike coming down. That's
And
right.
the footing was a little bit loose, but yeah, I just had to watch it.
Well, great. Well, I want to thank everybody for being here tonight. What a fantastic evening. And Tom, thank you again. We really appreciate it very much. Sooner or later we're going to get back to having our in-person meetings, and I'm looking forward to that. But until then, we probably have another month or two of this, maybe longer. Who knows? But it works, and it's fantastic, and it's good to see everybody. So, from the Elmering Committee, I'm going to say 73. And thank you to Wayne for working the technical piece behind the scenes. That takes a lot of work. Thank you for the rest of the board that's on here tonight. That's not only here, but does so much work for the club in the background. We appreciate it, Elizabeth and Ray and those other people that are out there as well. And the committee chairs and and I think I heard Justin say the prediction's 200 members by the end of the year. Is that what I heard? So that's fantastic. So 73 to all, and we'll talk to everybody on the nets next week.
All right.
Randy, I'd like to point out something to you. That's my amplifier. See, it's 500 watts right there. It's a small one, and you can haul it up, but unfortunately you have to bring a generator because it runs off 110, not 12 volts. So
I kept looking for the outlet and I couldn't find one.
Really? The Elecraft runs 110?
Yep.
Wow.
The 500, not the 1500. 500.
Okay, cool. That is
And
nice.
frankly, I want to get it up to about 200 or 220.
Wayne, bring your amp.
What, the Elecraft? Yeah, I could.
No, the other.
Yeah, right. If you're willing to strap it on your back and haul it up the mountain.
Hold it. He has
weighs
your Henry, right?
Yeah, I have the Henry.
Hey, that picture would go in QST, I guarantee it.
Right?
Huh.
Yeah, of me face down in the dirt with a Henry attached to my back.
All right.
Well, cool.
All right, guys.
Well,
Night, everybody.
Ladies,
7 threes. Have a good one.
73.
Yeah.
See you
Later,
later.
everybody.
Bye-bye.
Thanks all.